Hello, welcome to my Pre-Algebra review series. This video covers Chapter 1, Section 8, titled Looking for a Pattern. By the end of this video, you'll have reviewed the procedures for finding number patterns. Please leave a like if you find this video helpful. Give your classmates a heads up too. It will more than likely help them, and it certainly will help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment here in the comment section below. I read them and do my best to answer each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. So let's give it a try. Objective 1. Finding a number pattern. Math strategies in action. What do songs, computer code, and your body's DNA code have in common? All are based on patterns. Radios use patterns of electromagnetic waves. Computer code consists of patterns of numbers. And your DNA is made up of molecules that repeat in special patterns. You can solve many types of problems by finding and using patterns. Making predictions from patterns is a form of inductive reasoning. Okay, example 1a, real-world problem solving. And I think what this means here, the 1a means that there's going to be a 1b and a 1c or however far it goes, that this is a long problem with a number of slides to get through it. So what we're saying here, information, here's the information. News spreads quickly at Riverdale High. Each student who hears a story repeats it 15 minutes later to two students who have not yet heard the news, and then tells nobody else. So this student hears the news, 15 minutes later, that student finds two people, tells them who haven't heard the news already, so these are new students hearing the news, tells those two students, and then that person there telling those two students tells nobody else. If anybody else is going to hear the news, it's going to be from the two new students in the next period. Okay, so here, suppose one student hears some news at 8 a.m. How many students will know the news by 9 a.m.? So that's kind of the problem we're going to deal with right here. So first we're reading the problem and understanding it, and we're going to write down the notes about it to help us further the patterns and understanding. 1. How many students does each student tell? Well, each student can tell two new students. How long does the news take to reach the second and the third student? So these two here are the second and third student based on the first student. And so it takes 15 minutes. Okay, 15 minutes. Okay, now we're going to plan a strategy here to solve this puzzle. It says make a table to organize the numbers, then look for a pattern. How many new students will hear the news by 8:15 a.m.? Well, we're going to start at 8 o'clock with just one student hearing news, and he or she's going to start spreading the news 15 minutes later. So by 8:15 a.m., two new students are going to know the news. How many 15-minute periods are there from 8 a.m. to 9 a.m.? Well, we get 8:15, 8:30, 8:45, and 9. So we're going to say there are 4 15-minute periods. Okay, so the pattern is to add the number of new students to the number of who have already known, because we're going to accumulate how many students are going to hear the news. Well, you hear the first person that hears it, that person tells two, so now there's three people, the first one and the two new ones. And then each one of those two new ones, 15 minutes later, each one of those is going to find two new students and add those two into the roster. So you started with 1, then it went to 3, and now you're going to have 4 students hearing the news, so they keep accumulating. So the pattern is to add the number of new students to the number who already know, okay? Similar to this then. You have 1 plus 2 is 3, right here. That's the first student. The first one heard it 15 minutes later. He tells 2 or she tells 2, so now there are 3 students that know it. So the number who know at 8:15 is 1. The one student talks to 2. That's 3. Okay. 3 plus 4 equals 7. The number who know at 8:30, the 2 students that were new, plus the one that told them, there's the 3 they're talking about. Here's 3, okay, the total 3. And then we're going to add, because each of these 2 students here, one and student 2 and 3 are going to tell 2 people. We start with the 3, and then they're going to tell 4 people because they each tell 2. So when you add those up, we get a total of 7. The number who know at 8:30, that's the next 15-minute period, is going to be 7 students. Okay, that's because the 2 students talked to 4 students. So you had the 1, then the 2 students makes 3, and 4 students makes 7. So it says make a table to extend the pattern until 9 a.m. So we're going to see the next page to see if we can extend this pattern, okay? Okay, so now we're on example 1b, the second page. Now here's the extended table. We're going to extend to 9 o'clock on our table. So the table shows time, right here, time, and then 8 a.m., 8:15, 8:30, 8:45, 9 o'clock. There's our time periods that we're checking for. And we're going to use our table to determine how many students. So we see the number of new students told. So at 8 a.m., there was 1 new student, the first original student. There was 1. And that's the number of new students told at that moment by someone outside the school possibly. And the number of students who knew. And there's 1. So that 1 person, there's only 1 that knew. So that's where we're starting. 1 new person, that 1 new person was the sum total of all the people that knew, which is 1. Then at 8:15, this person here, right here, tells 2 people. And these 2 people are at 8:15 were the new ones. And how many now know the news? You have 1 from 8 o'clock and 2 from 8:15. So that's right here. 1 plus 2 equals 3. That's who know the news. 3 people. At 8:30, these 2 right here are going to tell 2 people each. So they're going to tell these 4 people. Well, these 4 people are going to now the question is how many now know? Well, you got these 4 people that were just told plus the 3 from before. So 3 plus 4, the 4 new ones, equals 7. Okay, so at 8:45, these 4 people tell 2 people each, and now we have 8 that were just told. They're brand new. Plus all the ones that knew ahead of time. So we had the 7 here previously, and now 8 more know. So we have 7 plus 8, and that equals 15. So at 9 o'clock, 15 minutes later, these 8 people tell 2 people each. They've just added 16 new people to the roster of people that know. And from this point back, we had 7 plus the 8. The new ones here were 15. And now we have 15 plus 16. They're just told here, 15 plus 16 equals 31. So at 9 a.m. in the morning, 31 people will have heard and now know the news. Okay? Finally, look back at and check. So we're going to look back at the chart and see what's going on, and we're going to look for patterns and this type of stuff too. One way to check the solution to solve the problem by another method. You can use a tree. Oh, so they will say, are there other methods for solving this same problem? We just used the table, this table right here. They now want to know, is there another method? So they said you can use a tree diagram, or you can just show it plainly, visibly with that tree, and it'll be kind of easy. You start off over here. You start with 1 person, and that person's going to tell 2 people, okay? And then those 2 people are going to tell 2 people, and here's 2 more people over here, people and a people, and now this one's going to tell 2 people, and this one's going to tell 2 people, and this one's going to tell 2 people, and then this one's going to tell 2 people. Can you see the problem that's happening here? There's a little bit of a problem, isn't there? I think we're going to answer that in the next slide. Anyways, so I haven't even gotten there. So now I'm up to 8, and I have to get to 16. So this one has to do 2, 1, 2. This one has to do 2, 1, 2. This one's going to do 2, 1, 2. This one, 1, 2. This person's going to tell 2. Here's 1 and 2. This person's going to tell 2, 1 and 2. This person tell 2, 1 and 2. And finally, this person's going to tell 2, 1 and 2. So there's a table. And if we count all these up, I'll guarantee, unless I missed one, there's 31 of them. And that's by 9. So we started with 1, then we had 2, then we had 4, and then we had 8, and then we had 16. Okay? So here's a table doing the same thing. At 8 a.m., we had 1 new student and 1 who knew. At 8:15, we had 2 new students, and now 3 know. At 8:30, we have 4 students told, new students, and 7 that previously knew. So they keep adding up as you see that. It's almost like the number who knew plus the new ones. The number who knew plus the new ones is equal to the total. So the number who knew plus the new ones equals the total that now know. And this goes on. Here's a pattern. The number who knew, the new ones plus the number who knew. And the new ones plus the number who knew. So 15 plus 16, 31. And same, there's a little pattern going on. There's truly a pattern for solving this. Okay? Okay, so now example 1C from our real world problem. So 5, describe 2 ways to find the number of students who will know the news at 9:15. Well, if we extend it, they want to find 2 ways to do that. What we do that is by extending our table. We just go to, our table ended at 9, and now we want to go to 9:15. So all we have to do is extend the table 15 minutes. And we'll have our answer. If we go back, we'll have our answer. Okay? Suppose you want to continue the pattern beyond 9:15. Here's where that little trick comes in. Beyond 9:15. Which would work better, the tree or the table? And what do you think, why? Well, did you see the problem I was having when I was drawing the tree? The tree got really kind of crazy and wild, didn't it? So what happens if you get to 9:15, then 9, so you go from 16 to 32 to 64 dots to 120, it goes 128 dots. It goes on and on and on. It gets crazy. But the table is just a little, you just add another list of 2 items to the table each time. The table gets longer, but it's very easy to maintain. So that's the reason why, because the tree is difficult to maintain and to keep building. 7, there are 251 students in Riverdale High. By what time will every student know the news? Well, that's interesting. How are they going to know? So we ended up with, on our table, what did we end up with? We ended up with going with 1 and 1. So this is new and old, I'll say. So then we these two, this is the beginning. Then we had 2 and 3, right? And then we had 4 and 7, because we're adding this one to get this one. And then now we're going to have 8, because we're doubling that each time. 7 and 8 is 15. And then 50, so now we're 16. And 15 and 16 is 31. And then 32 is 63. After 30, what is this? This is 8, 8:15, 8:30, 8:45, 9, 9:15. Okay. Then we have, this goes to 64, and then the number goes to 127. That's by 9:30. And 127, the 64 goes to 128. And 127 and 150 is 255. Okay, so now there are 251 students at Riverdale High. So by 9, so here was 8, 8:15, 8:30, 8:45, 9, 9:15, 9:30, 9:45. 9:45 is the time, because at 9:30, only 127 students knew the news, but there are 251 students. So in order to get to the 251, we had to add in the next lot, which we had to do this doubling here, which now gave us this extra 128 added to this 127 to get 255, and 255 is greater than 251. So by 9:45, all knew. Okay? Okay, so example 1, check your understanding. Extend the table, right? That's what we're going to do. Here's the table. We're going to extend it. So suppose each student who hears the story, it's the same story with a little twist to it, repeats it in 10 minutes, not 15 minutes. How many students will know the news by 9 a.m.? So we're just going to do the same thing we did, and we're going to check our understanding, right? So it wants to know how many. It doesn't say the limit. It just says how many students will know the news at 9. So I got that selected. So at 8 a.m. in the morning, right here, at 8 a.m., there's one new student, so already knows, and it's 1 and 1. We start with filling in both blanks. There's one student that knows at 8 a.m. It's the total number that's new, and that's the total number that know. Okay, so at 8:10, we're going to double our number here, the 1. We're going to have 2. Okay, and then 1 plus 2 is 3. It's the same pattern. So now we're going to double this. We're going to have 4. And 3 plus 4 is 7. And now we're going to double this at 8. And 8 plus 7 is 15. Okay. Now we're going to double this to 16. And 16 plus 15 is 31. Okay. And we're going to 850. We're going to double this to 32. And 32 gives 63. Okay. 32 gives us 64 as a doubled. And 64 and 63 is 127. So are we there yet? We want to know how many will know at 9 a.m. Bingo, we've arrived. 9 a.m., 127 students are going to know. And if we carry that one step further, we're going to have 128 at 9:10, 127, and 128 is 255. But they wanted to know this one here. At 9 a.m., 127 students know.